Unit analysis is a very formal way of solving a problem. It has a definite script and a definite set of procedures. If you were an expert at the script and procedures of unit analysis, you can get very close to solving just about any problem. Now, it can't do everything. There are certain kinds of problems that it can't solve, but it is certainly the most common way that books will solve problems in both chemistry and often in physics as well. If you're going to continue in science, you should have some familiarity with unit analysis. Now, folks, this page here is not about finding the final answers. I'll go through and find the final answers for you, but this is really about the process. This is really about exposing you to the script and procedure of unit analysis. So all problems, all questions always have two parts, the given information and the question. So here's the given information here, 24 BIFs, and here's the question, how many shanks? So I couldn't ask you, hey, how many shanks is it? Because you would ask me, well, how many shanks is what? What am I starting with? So you always have to have that starting information, and that's what unit analysis starts with. So 24 BIFs is equal to, now you'll notice how much space I left after the BIFs, because I just don't know how much space I'm going to need to solve the problem. And after the equal sign, I'm going to write the kind of answer that I'm expecting. In this case, shanks. Now, students are always concerned with just finding the answer, and they just write down the numbers. Unit analysis cannot be done with just the numbers, with just the measurements. It's an analysis of the units. It's the analysis of the units that help you figure out what to do step by step and how to confirm if in fact your answer is going to be correct. So those are just as important as the numbers in the problem. So now the script. BIFs equal shanks. Well, of course, BIFs are not equal to shanks. If the units ever fail to match on both sides of the equal sign, you always respond the same way, and that is by multiplying by a fraction, which you can see I've just done in blue. So the BIFs do not appear in the answer. I need to cancel the BIFs, much like I would cancel x in an algebraic expression. So where would I have to write BIFs in this new fraction so it cancels with the green BIFs that I wrote at the start of the problem? Well, the 24 BIFs are understood to be on the top of an imaginary fraction, so I'm going to write BIFs on the bottom because something on the bottom cancels with something on the top. And now I have effectively gotten rid of the BIFs. I still need something for the top of the fraction. And let's face it, I'm trying to end up with shanks, so I'd like to put that on the top. So now it's back to the script. Analyze the units. Shanks equal shanks. Well, that's true. So this was the right thing to do. The only thing I don't have filled in yet is the relationship between shanks and BIFs. And this is where specific content information from the course comes from. This is where you would need to know about chemistry and not unit analysis to fill in this relationship. Now, not in this case because these are just made up units that I created one day. So this is why I provided some background information. So here's the background information. 7 BIFs is equal to 1 shank, and 3 shanks are equal to 1 Kroll. Well, if 7 BIFs are equal to 1 shank, that means that I'll put the 7 with the BIFs and the 1 with the shanks. And now I'm ready to solve the problem. Now, solving problems like this, students sometimes solve in very unusual ways. I would say treat this like words in a sentence. We read left to right and top down. So I would read this problem in this manner. 24 BIFs times 1 shank divided by 7 BIFs equal shanks. 24 times 1 divided by 7 equals is the way to go. Now, of course, multiplying and dividing by 1 doesn't do anything, so I wouldn't waste my time pushing those buttons. So it's 24 divided by 7, and that gets me a lot of digits in the calculator, right? You should be calculating this along with me. And I have to round this to the right number of sig figs. So I'm just going to write down a couple digits here. So here's my calculator window. 3.4285, and so on. So the 1 and the 7. The 1 and the 7 are defined values. This is exactly what a BIF or a shank is. These are not measurements. So they have an unlimited number of sig figs, and that's common when you fill in the fractions. Almost in every single case, the number that you start with, in this case the 24 BIFs, that's the number of sig figs that belong in your answer. So I must have 2 sig figs in my answer. That's 3.4. Now, you may have looked at this problem and said, I know what to do. I need to divide by 7. Listen, if you understood that at the beginning of the problem, then you would never waste your time setting up and solving a unit analysis problem. You would just do it. Unit analysis, to my thinking, is best used when you're not sure how to solve a problem. That is when unit analysis really becomes handy. And I'll show you an example of that for me by the time I'm done with this video. Now the next problem, 33 Krols is how many BIFs? So we're going to start with our given information, 33 Krols. Going to leave space, and we're searching for BIFs. So the script, Krols equal BIFs. Well, they're not equal, so I'm going to respond by multiplying by a fraction. Krols are not in the answer, just BIFs are, so I need to cancel the Krols. The way to cancel the Krols would be to write them on the bottom of this fraction. Something on the bottom and something on the top cancels. Now, don't write anything yet, all right, until I tell you to. But think about what we would normally do next. We're trying to end up with BIFs, so wouldn't it be great to write BIFs on the top? Now you could do that except for one problem in this case. Nowhere does it say how many BIFs are in how many Krols. That's not part of the given information. So putting BIFs on the top is not going to help me. Now sure, I could do a side problem and figure out how many BIFs were in a Krol, but you never ever do side problems in unit analysis. It's just not done. So the best I can do is relate Krols to something else. Shanks. Yes, I want to end up with BIFs, but I don't have any way of doing that with one single fraction. So now Shanks and Krols, what's the relationship? Well, that's in the background information. 1 Krol is equal to 3 Shanks. So for every 3 Shanks, there's 1 Krol. Back to the script. Shanks equal BIFs. Well, that's not true. So I'm going to respond by multiplying by a fraction. Same as I did every other time that the units didn't match. Shanks do not appear in the answer. I need to cancel the Shanks. So I will write those on the bottom, because something on the bottom cancels with something on the top. Now Shanks are related to both Krols and BIFs, but I'm trying to end up with a final answer of BIFs. So that is what I'm going to put on the top. BIFs equal BIFs, they match. This is the right way to set up the problem. The only thing I have to do is fill in the relationship between BIFs and Shanks. Well, we've used that relationship before. There's 7 BIFs in every 1 Shank. Now the 7 and the 1 here, I don't have to fill in a 7 and a 1. I just have to fill in a set of numbers that's true. 7 over 1 is true, but so is 14 over 2. So is 21 over 3. So is 0.7 over 0.1. Any set of numbers that creates the correct relationship between BIFs and Shanks in this case is fair game for this fraction. All right, so all that's left to do is to punch it in. Now the problem reads as 33 times 3 divided by 1 times 7 divided by 1 equals. Of course, I'm not going to multiply or divide by 1 because that doesn't actually do anything. So it's 33 times 3 times 7 is equal to 693 in the calculator. But I'm only allowed 2 sig figs. Here's my first sig fig. I'm only allowed one more. Here's my second. Now, putting a rounded answer of 69 when the calculated answer is 693, there's no direct connection between those two numbers. They're different by a factor of 10. So we've agreed on several occasions before this that the rounded and calculated answer must be very close to each other. So the rules for multiplying and dividing say that the number of sig figs in my answer should match the number of sig figs in the problem, the fewest number of sig figs in the problem. Well, I have that. I have the 2. But that doesn't mean that I can't write an insignificant 0 on the end to make the rounded answer very, very close to the calculated answer. And you saw this in some of the other practice problems that we did. So the most correct answer here is 690 BIFs. Again, if you could look at this problem and knew to multiply by 21, you would never have wasted your time setting up the unit analysis. But if you're not sure how to solve the problem, this provides a framework. All right, 111. 1 xipod is equal to how many Cincos? All right, so the script. Xipods equal Cincos. Well, that's not true. They're not equal, so I'm going to multiply by a fraction. Xipods must be on the bottom. They cancel with Xipods on the top. Xipods, are they related to Cincos? Well, not directly, so I can't do this in one fraction. But I can relate Xipods to La Loops. And it says that there's 0.3 Xipods in 15 La Loops. So there's 0.3 Xipods in 15 La Loops. So a lot of times students struggle with which unit gets which number. Where does the 0.3 go? Where does the 15 go? And all I would tell you for that, folks, is to make it match the background information. The 0.3 went with the Xipods, and the 15 went with the La Loops. Do the same thing in your unit analysis problem, and you'll have the right relationship. Back to the script. La Loops equal Cincos. Well, no, that's not true. So I need to multiply by another fraction. La Loops do not appear in the answer. They cancel. Cincos go on the top. The relationship is that there are 4 La Loops for every 30 Cincos. Cincos equal Cincos. This is it. We're done. Now, in some cases, you might need a third fraction. In some cases, even more. So in this case, we have 1 times 15 divided by 0.3 times 30 divided by 4 equals. The calculated answer is 375. That appears in the calculator. But the number of sig figs that we started with was 1. So our answer can only have 1 sig fig. It's not 4. 400. 400 Cincos is the correct answer. Now, of course, those were all made-up units, right? Biffs, Shanks, La Loops, and so on. They don't exist. And I did that because I wanted to have problems that you had no prior experience with. If I had used inches and feet, for example, you would have used your innate understanding of those units to figure out what to do. I made up these crazy units to force you to use unit analysis, because that's the point here. All right, so 114 is circled. There's something unusual about that that totally has to do with sig figs, but I'm not going to elaborate on it. All right, so 115 is a problem that you could all sit there and do. You could take out a calculator, and I'm sure everyone could get to an answer. You would just go step by step by step. I just want to do it using the formalized technique that we call unit analysis. So we're going to start with the given information, 1.2 centuries. And what I'm trying to end up with is days. So centuries equal days. Obviously, they don't match, so I'm going to multiply by a fraction, and centuries are on the bottom. centuries on the bottom, cancel with centuries on the top. Now, if you want to get this done in one fraction, you certainly can. You can put days on the top. But if you want to put days on the top, I need to ask you, how many days in a century? See, no one tends to know that because we don't define centuries by days. We define centuries in terms of years. So 1 century is 100 years. Years equal days. Well, that's not true, so we need to multiply by a fraction. Years are on the bottom. They cancel. And years and days are certainly related. In every 1 year, we have approximately 365 days. Days equal days. This is the way to get to the answer. 1.2 times 100 times 365. Calculator says 43,800 days. But we started with 2 sig figs, so we have to finish with 2 sig figs. And that makes our answer, our rounded answer, 44,000. Now, if you needed to go past days and go all the way down to minutes, like in the next problem, that would just require some additional fractions, right? And everyone should try to make that happen. Now, I wanted to show you an example of a case where I would resort to unit analysis. So 117. Now, yes, this does mention the metric system. We have not reviewed the metric system yet. All right, that'll be our last topic for this section. But there's really no way to avoid that, folks. So I'll fill in the necessary gaps in the metric system when we get there. So we have a rate or a flow rate. You go to the sink, you turn on the faucet, and in 1 minute, 15.01 liters comes out of the faucet. So we have a fractional unit. So liters over minutes. And what we want to do is convert that to milliliters per second. So because we have a fractional unit here, we don't want to convert one unit, we have to convert both units. And the key to understand is that you can't convert them both at the same time. You have to do one, then you can go back and fix the other. And that's exactly what we're going to do. Now I'm going to start with the time units because we're all so familiar with units of time. That would be the minutes. So liters per minute equal milliliters per second. Not true, so we're going to multiply by a fraction. Minutes do not appear in the answer, so I'm going to write the minutes on the top now because something on the bottom cancels with something on the top. So that's slightly different than any of the problems we've done so far. Minutes are related to lots of things, but of course we want to relate them to seconds. 1 minute is of course 60 seconds. Now right now, at this point when we analyze the units, we have liters per second equal to milliliters per second. So we're closer, but we're not quite there yet. Because the units don't match, we need to multiply by another fraction. In this case, we need to get rid of the liters. Liters were originally on top, so we're going to put them on the bottom because something on the bottom cancels with something on the top. Liters are related to several things, but we're going to relate them to milliliters. So here's the part that I'll fill in. Every liter is 1,000 milliliters. Now when we analyze the units, we're left with milliliters per second on the left side and milliliters per second on the right side. So no more fractions. So now this is 15.01 times 1 divided by 60 times 1,000 divided by 1 equals the calculated answer of 250.16 repeated. I started with 4 sig figs, so my answer must have 4 sig figs, 250.2.